Hello everyone, welcome to week 2 of Data Engineering Zoomcamp, and in this week we will talk about workflow orchestration or orchestration in general. In this video I want to talk about the concept of workflow orchestration and give you some theoretical background of what it is. So there will be no code almost, and I'll try to explain what it is. Last week, remember, I gave a very loose definition of what a data pipeline is. So a data pipeline is, let's say, a script or a bunch of scripts, a job that takes in one or more data sources, then does something with this. So this is the input to our data pipeline, and then it produces one or more data sets as well. So this is our data pipeline. And in the previous week, we actually created something that we can call a data pipeline. Let me show you in week 1 in this Docker SQL. So we have this ingest data script, which sort of might qualify as a pipeline because it does get data as input, it does produce data as output, and then it's doing something with this data. In particular, what it's doing, it first downloads the data from some location, then loads this data with pandas, and then inserts this data to Postgres. So this was the pipeline. We called it the ingestion script, ingest data script that we created in the previous week. Let me draw it here. We have some CSV file that lives on the internet. Then we have this ingest.py script, ingest data.py, that does a few things. So first it uses wget to actually download this data, then it stores it locally as a CSV file, and then we use the rest of the script, so I'll just call it script, to put this data to Postgres database. And this is actually a good example of how we should not write data pipelines. And the main reason for that is that this step, so actually inside one job, we have 2 steps. So we have the first step that downloads the data, saves it locally, and then the second step that inserts this data to the database. So ideally, we should somehow split it. And the reason for that, so imagine something happened with the internet and it's just for 30 seconds, for example. For 30 seconds, the internet is not available, but our entire script will fail. Or for example, here, we downloaded something successfully, but then we start inserting, and then there is an error with connection to the database. We actually saw this in one of the videos in the previous week. So there was some issue with connecting to the database. We had to download it again. And let's say if connection is slow and it takes 10 minutes to download a CSV file, then we have to redo this one more time. And we also need to add some retry mechanism. So let's say if file is temporarily unavailable, let's try after 30 seconds. And here we should also do some retry, add some retry mechanism, like do something after 30 seconds, for example. So then if we want to modify it, do this in this script, then we will need to do something like while not successful, do this, and then for example after each attempt, if not successful, then maybe sleep for 10 seconds or 20 seconds and then do this. And of course we don't want to repeat this forever. Maybe we only want to do this for 5 times before giving up. And then we also want to do the same thing here while not. This is actually not valid Python code, of course. This is just more like pseudocode. So ideally what we want to do with this is we want to split it into multiple files. Let's say we can create first file, which is download data, and then the second file, the second script, ingest CSV to Postgres. So we need to split this. Let me rewrite it. So we'll have 2 steps, wget, and then ingest. So the source for this is data coming from the internet. Then this thing creates a CSV file. And then finally, this ingest script puts the data to our Postgres database. The whole thing, we can call it data pipeline because remember in the definition I gave you, a data pipeline is a job for multiple jobs that read data and produce data. This is still true for this one as well. So I'll call it data. And this data pipeline is actually parameterized. So each job here, so this job has a bunch of parameters. The parameters are, we can see them here. So these parameters are user, password, host, and so on, table name. So there are some params here. And this thing also has some params. And this means that the entire data pipeline can have some parameters. So for example, for this data pipeline, the parameter for the pipeline is URL. because we can take this data pipeline and just rerun it for a different URL. But these parameters for the ingestion script will probably stay the same. So we can say that this URL is a parameter that defines our data pipeline. Alternatively, it could be, for example, month, in our case, which is January. So we don't parameterize the pipeline with a URL. We just say that we want to run this for month that is equals to 2021-01 January. So I think that was the month we used for that data pipeline. And we can re-execute this pipeline for different months. So for example, for February, for March, and so on. What are the ways that we can implement this? So one way could be we can just write everything in Python like we did. Maybe we can have 2 Python files, 2 scripts, and I don't know, 1 bash script that glues everything together. This is not super convenient because then we will need to think about all this retry logic, like how can we retry, when should we fail the entire pipeline. We will need to think about many things. And then we also need to specify things that need to be run in the correct order. So for example, we always need to run this first, wget script first, and then run ingest. So the ingest job depends on wget. Before running ingest, we have to make sure that wget is executed. For example, for that, we can also use make. This is a utility that allows to specify these dependencies. We can say that ingest depends on wget, and when we say make ingest, we will not do this. It's just for example. We can specify that ingest depends on wget, so then make will arrange things in such an order that first we execute wget and then we execute ingest. Yeah, before I talk about the actual orchestration tools, let me give you a slightly more complex example. So this is now what we did last week. But this week we are going to do a more complex example. We will again have a CSV file that comes from web. So then we will do, I'm not sure if we will use wget, maybe something else, but we will download this file and then produce a CSV file. So the result of this first step will be a CSV file that we store locally. Then CSV file is not the most effective format. We want to use a more effective format. And here in this course, we will use a format that is called Parquet, which is just a more effective way of storing data on your disk. So and then the job that we will do this, we can call it, I don't know, Parquetize. So it's just a Python script that gets the CSV file, reads it, and saves it in Parquet file. Then we want to take this Parquet file and upload this to a Google Cloud Storage. Upload to Google Cloud Storage. And the result of this step would be the same Parquet file, but in Google Storage. And then finally, we can have another job that takes this Parquet file and uploads this to BigQuery. And the result of this thing will be table in BigQuery. So you see, this is getting more and more complex. So we actually have 1, 2, 3, 4 steps. Each of these steps gets some data as input and produces some data as output. And then there is some dependency between these. So for example, this fourth step depends on the third step that it expects that it already uploads data to GCS. So we need to make sure that we execute these things in this order. So first we execute this one, then we execute this one, and this one. And let's say in addition to uploading to Google Cloud Storage, maybe we have another thing. So we will not do this here, it's just for an example. Maybe we have another job that uploads the same Parquet file to Amazon S3, for example. So it takes the same Parquet file that the job number 2 produces, and it runs in parallel to job number 3. So it will be, I can call it 5, but this is something that can run in parallel to job number 3. So this is still a data pipeline. You see, it becomes more and more complex, and that's why this thing is also often called workflow, or we can call it data workflow. So it specifies how exactly our data flows, what are the dependencies, what are the jobs there. And we see that the jobs here are these rectangular things. So these are the jobs. And then the dependencies, the result, and then dependencies are these files that our jobs produce. So the next job depends on the previous job output. So it needs to make sure that the output is there. So this is called data workflow. And sometimes it's also referred as DAG, which is short for directed acyclic graph. because this thing that we just created here, so this is, we can see this as a graph where these things are nodes here, they are the jobs, and the edges between these nodes are the dependencies, the data that we produce. And the main characteristic of this DAG, well, it's directed. So we have these errors here. We can see that packetized job depends on wget because wget produces a file output that packetized job needs. So this is there is this notion of direction. We know which job depends on which one. And then there is the other word, which is acyclic, which means that there are no cycles, no loops. And the loop would be when, let's say, after we upload maybe data to GCS and then we go to this step. So this would be an example of a graph with a loop, with a cycle. And in this case, we don't know whether we should run this one first or this one. So there is no clear dependency which should go first. So in this case, a graph has a loop, a cycle, but data workflows are usually cyclic graphs. So they don't have any cycles. They don't have any loops there. And these data workflows, or I can call it again data pipeline, I use these words as synonyms. So this data workflow has some parameters. For us, parameter of this specific data workflow could be month, 2021, January. So this is a parameter for the entire workflow. And then each job would have its own set of parameters. Now we are coming to the actual topic of workflow orchestration. So we have this workflow, but how do we actually execute this? How do we make sure that we first run job number one and then job number two? How do we make sure that we have some sort of retry mechanism for this one, or retry mechanism for this one? So for example, uploading to GCS, many things can go wrong there. So maybe something is wrong with our internet connection, maybe something is wrong with GCS, it's temporarily down. So we need to have an easy way of retrying things. And workflow engines as tools, they let us define these directly acyclic graphs, workflows. They let us parameterize these graphs, and they have this retry mechanism, they have the history, they have the logs, things like this. So everything we need for executing our data workflows. Data workflow orchestration. And for that, there are many tools that exist that can do this. I think I mentioned Make, but using Make is something that you of course can use it, but this is something you would run just on your laptop. You would orchestrate with Make smaller workflows, not data workflows. But there are tools that are created specifically for defining data workflows, and one of them is called Luigi. This is actually my favorite data workflow orchestration tool. It's not very popular. I think these days it's not very widely used, because there is a more popular tool which we are actually going to cover in this course. It's called Apache Airflow. And this is what we are going to use in this course. Any data workflow orchestration tool allows us to specify our data workflows, parameterize them, and rerun, and so on. Maybe just for completeness, I can mention another one. It's called Prefect. There is also Argo, I think. And there is quite a lot of them. So they all let you specify this dependency graph, this workflow. They let you specify these individual steps in the sequence of steps. And then it's up to you how you implement this. We'll use Airflow because this is one of the most popular data workflow orchestration tool that exists right now. And probably as a data engineer, it's very likely that you will need to use this tool at work. So that's all from me. So in the next video, you will actually see how to use Airflow. So see you there. Bye.